So welcome to day 2. Got it. It's being recorded. It's telling me that. Nice. It's nice that it tells you that. Yeah. Okay. So what we're going to do today, let me just share my screen. Okay. A lot of stuff going on. And present here. So what we're going to do today is just do some short coding exercises, okay, for the first 15, 20 minutes. And these will be based on what we did in day 01. So it's a kind of repetition, but it will get a chance to just look at each individual concept by itself and just explore it a little more and tease out a little more knowledge about it along the way. Nuggets is about knowledge. So this bit is PowerPoint, and this is going to be the second 15, 20 minutes. And I do want to take some time out to talk a little bit about the engineering underlying some of the, for example, sensors or layouts, okay? So we'll spend 15, 20 minutes on that. And then we'll get into another demo for the last 15, 20 minutes. So a lot of times a web application is basically a mobile kiosk around a web page. And web pages are built in HTML, CSS, and JavaScript. And so we need to know a little bit about this. It's not mandatory for building apps in App Inventor, but it does give you a powerful way of extending the native abilities of App Inventor. So I'll do a demo just about layouts in HTML and CSS and kind of the minimum viable product. What's the minimum you need to know about HTML and CSS? We'll cover that. So without further ado, let's jump in. If you're going to be coding along, feel free to do that. The files are posted in the Google Classroom. And I'll do my best to go at a pace where you can keep up. Let's start with, how do you click a button? So this is all that we'll be going through, okay? And let's start with, how do you click a button to make it red? Very simple, right? So if you're coding along, you'll go to the how to click a button to make it red. And as I posted on the forum, my Android phone from 1996, I think, finally died. So I'm waiting until Thanksgiving to get a new one. I hope to get a good deal. So everything will be in the emulator. All right. So what are we up to here? Let's see. Let's go to the emulator. There we go. All we are doing is this entire app just has a click me button, right? And what's the magic that happens when I click me? It turns red. Wow, how about that? So how do we do this? So let's go to blocks. So this entire app, the designer, there's a screen and just one button. That's it, okay? And I'm going to delete the blocks so we can code. And the code is basically go to the button element. And by the way, the issue I was having with layouts last time was because of an extension I downloaded for Opera. So I could zoom in while making this presentation. And unfortunately, it was interfering with the natural flow of using App Inventor. So I uninstalled that app. But the downside is now I cannot zoom in, okay? So you're going to have to live for a while with this zoom setting, okay? But if you're having some issue, just type something in the chat box and let me know. But I hope you can see what I'm doing relatively well enough to be able to follow along. So I'm going to, now I'm in the blocks. So I'm in the coding canvas. I'm on the coding canvas and I'm going to the button. I clicked on it and I'm just grabbing the button click event, right? And what we want to do, we want to change the button's color to red. So where do you think we need to go? We need to go back to button. We need to find the property color, and that's background color. And when you look at the properties, there's a set method, just a reminder, a get method, which is this light gray color, and there's a set method. So the get method will tell you what the color is, and the set method will allow you to change it. So which one do you think we need? It's obviously the set one, right? And now we are almost there. And this is called an event handler. The green part is called the event, which is a button click. Just a reminder from last time. And the code inside the event is called a callback. Okay, so the callback is just one code block right now. Set button background color to, and to what? So where do you think I'll find colors? Yeah, so helpfully there's a colors drawer, and I can go there and grab the color red. Okay, and that's it. And first of all, let's make sure that this is working. So I go back to my app. Now, since I already did this once, I'm going to have to refresh the companion screen. So go to connect, refresh the companion screen. So it kind of starting over inside the emulator, click me, and the button turns red, right? And that's it. So the reason we are going over this again is because an app is basically nothing but a set of event handlers, right? There's nothing else in an app except an event and a response. And you have the event and then you have the callback, which defines the response. And if you're, let's say, oftentimes in coding, we start with an app that someone has already built, like the files that I shared the last time from the completed Soundboard app. You might feel overwhelmed looking at the code, like what is all going on here? The easiest way to understand code is to just list down all the event handlers. What is the event and what is the response? And within a few minutes, you will have understood 80% of what the app does, right? So this is just something to take away from here, all right? One little add-on to this is when we went to the colors drawer, we saw all of these colors, right? And what if I want a color outside of these? I mean, this is a very limited set of colors, right? There's no silver, for example, or yellow ochre or aquamarine or all of those wonderful magenta, all of those wonderful colors. Oh, magenta is there, I think, but yeah, I'm colorblind anyway. So what if we want a different color? So in that case, there are a number of things we can do. For example, there is this make color. And if I don't want red, every color is basically a combination of red, green, and blue. So each value goes from 0 to 255, right? So I'm going to get rid of this one. Again, moving things around. Yeah. So another way to tell it, make the button red, is to give it the RGB codes, right? So right now, red is 255. So red is all the way maxed out. Green is 0, blue is 0. So it should be doing the same thing. Let's go back to connect and refresh the companion and click me, and it's red. Thank God. Yeah. Okay, so there's that. There is one other way, actually, a much more other than RGB. And by the way, if you want, oh, there's a comment. Where are the materials from the last session? Need to catch up, please. Yeah, it's in the, just go to the Google Classroom.
I'll post it. Or are you, oh, you're talking about the materials, sorry. I can post the link to the recording.
Yeah, and the materials are all shared. Let me just show you where. So if you go here, oops. Okay, get rid of this one. No, I made it worse. Okay, get rid of this one here. Okay. You go to the Google Classroom. Are you on there? Oops. If you're not on there, send me or Nikki an email and I'll get you there. But I've posted it here. Okay, the starter app. This is what this is if you want to follow the checklist and build it. The completed app. If you want to compare once you have done your work with what we did in the last class, and then if you just want to download it and see how it works on an Android phone, then that's the last link. Okay, so everything is shared. Anything else? Okay, thank you, Nikki. Yeah, any questions about this one? I see a few more people have joined. Welcome. We're just getting started. Yeah, and the colors are a fascinating topic in themselves. In fact, there's the last way to specify colors. If you want like any color in the world is hex codes. Okay, so for example, if I want a color like silver or aluminum, you could just type hex code silver or aluminum. And these hex codes, they kind of look kind of wonky, right? It is a hash followed by these 6 letters. Actually, the first 2 are red, the second 2 are green, and the last 2 are blue, right? So it is still red, green, blue. But this is becoming the most popular way of specifying colors. So you have this option as well. All right. So this is all about colors. I'll go back to projects and the event handler. All right, what's next? How do you ask an if question? So if you remember from the app we built, we tried our hand at this already. Now let's just do a deep dive into if. Okay, and what I have here is actually a rather ugly looking app, but what it does is, let's see what it does, right? Let's go to the emulator again. Yeah. I think when I click on this smiley face, it's going to start playing a recording, some classical composition. And then if I click on it again, it's going to pause and click on start, stop, start, stop. Yeah. So we turn up the volume just for the demonstration purposes. Do you hear that? Now I'm clicking on this and it's paused, right? And I click on it again and it started again. Okay, it sounds pretty awful, but yeah, I'm going to turn it down. So what is happening here is when we click on the button, we want to detect if an audio clip is already playing. And if it is playing, then we want to do something else, right? Then we want to pause the recording, right? So that is the use case, the classic use case of an if-then statement. So let's go to blocks and see how to implement this. I'm going to delete the blocks as before and just code this from the beginning. And in the designer, you'll see that, and hopefully you can see these, right? Even though it's a little bit small, but yeah, there's just a screen and a button and a player, all right? We've used all these components in the last one. And all I've done is I've taken the button and changed its properties to make it look like this smiley face by giving it an image. So the image is here, okay? You can actually preview it, okay? From the media drawer over here, close it. The sound clip is also there and you can preview that also. Yeah, so that's all I have. And what we want to do is when I click the button, yeah, I want to just start playing. We know how to do that, right? We go to the player and we start. There's one little point of note here. Let's go back to the designer. When I go to the player, I have set its properties, source to the MP3 file, right? This is not the only way to do it. You can go to the code and you can go to the player and which of these blocks, what block would I be looking for? So I'd be looking for a get set method to set the source, right? So here are the get set, move the zoom thing out of the way. Yeah. So here are the get and set methods for the source. And this is a way to tell it in code what is the source MP3 file to play. So this is just another way of doing it, okay? These blocks over here. We won't be using these now. What we'll do is just start playing. And as I said, what we will do is we want to check if it's already playing. So let's go to the control drawer where all the good stuff is. We're going to take an if-then statement, right? And plug it in to the event. And what do we want to check for? So this is all conditional checking. So we want to check if the player is playing. So there's a get method to tell us that. Yeah, and all these conditional clauses, this is a conditional clause. We can compare numbers, strings. We can check certain properties, what values they hold, like for a player, the relevant property is it playing or not? The conditional clause must always evaluate to a binary, a true or false, right? So like the COVID test, right? It's true or false. You either have it or you don't. So the if, what you put next to the if has always got to evaluate to true or false. That's the only thing you need to be sure of, okay? Make sure of. And then what we want to do, we want to pause it. So we go back to the player, we pause. And now let's test that this is doing what we were observing before. And sorry, when it plays the sound recording in the emulator, it sounds a bit jarring. I don't know why that is. It's actually a beautiful classical composition, but anyway, we won't worry about that. Here we go. Okay, I click it. Okay, nothing happening, right? So let's turn it on the way down. We need to refresh it. Let's make sure it's playing the right code. It's a bit strange. Okay, we'll turn it all the way down. Let's do one thing. Let's make this an if then else statement. So what we'll do is if playing, then pause, else start. Go to the play, start. It should do it. Refresh the companion screen. Let's try that one more time. Hopefully it works. Can any one of you tell me what I'm doing wrong here? It's just going to close it and start it over again. Just look at the code and see if you can debug it. Okay. I have a feeling that the emulator is not updating and not keeping up. That's what I think is going on here. If not, we'll just circle back to it later. Okay. These things do happen. All right. Emulator. Is playing, then stop and start. Let me see if there are any messages in the chat box. So I guess you're all following along. Okay, should have started. There we go. All right, let's start. Playing. Yeah, it stopped, right? Pick it again, and it's playing. Okay. There was a little glitch there. I don't know what, but I'm guessing it didn't reflect. So I've turned up the volume. I click it, it stops. I click it, it plays. Okay. Okay, that's enough of you, buddy. Get out of here. Okay. And so I was talking to the app, the smiley face. All right. So yeah, so this is an if else statement. And there's one little thing I want to show you here, which is that let's go back to the app that we built the last time. I have a dream app. So here it is. Yeah. So what I did is I also modified this code a little bit, because if you remember the last time, we could touch the button to check if the other clip was playing before playing the new one, right? But there was no way to stop any click, or there was no way to stop any recording from playing, right? So if you remember from the last time, we had this if then statement. So if we are clicking on the Martin Luther King button, it would check if the Malcolm X recording is playing. If playing, pause it, and then start the Martin Luther King speech. But we had no way of actually pausing anything, right? It would keep playing forever. So I added this if then else statement to check also if the Martin Luther King clip is playing. So let's see how this works, right? I hope you're following. So, oh, you see there's a little bit of a lag in refreshing the emulator. That's what's going on. Okay, thankfully, if you go to connect and refresh companion screen, that should do it, right? So let's turn this all the way up, or maybe not all the way up here. Click Martin Luther King speech. So last time, now if I clicked on the Malcolm X button, it would pause the Dr. King's speech and play Malcolm X's speech, and vice versa. Now with this modification, I click on the same image twice, it will pause it, okay? Click it again, play. Click it again, pause. Click it again, play. Okay, hope that makes sense. Hope you're following along. If not, type in the chat box. But a little change I made was going from this, right, to add this bit over here, yeah? And the reason I'm showing you this is with these if-then statements, it doesn't have to be limited to testing one condition, right? You can have as many branches as you need and test a number of conditions. The only thing to be aware of, the only point to be aware of is that each condition, each individual condition must evaluate to a true or a false, okay? That's it. Let's keep going. How do you have the app talk when the phone is shaken? All right, let's do that. How do you have the app talk when the phone is shaken? So now, by now, you can pretty much guess how to do this yourself, right? Let's just play this app in the emulator. You can pretty much guess what is the event that you will need, what do you need to do in the callback. I'm pretty sure now you can just look at the description of what the app should do and do some of that initial figuring out, right? And what I have here is, let's see, what do I have here? Speak, friend, and enter. Okay. Do you remember from Lord of the Rings when Frodo and the Fellowship, they arrive at the entrance to the dwarves' caves, and there is a cryptic message there in Elfish or Dwarfish, and it says, speak, friend, and enter. And yeah, this is a silly version of that. And if you speak friend, if you type friend, it asks you to type friend. Okay. The keyboard comes up automatically when you use a text input. I'll go into that in just a little bit. And then click on.
You may not enter.
Yeah, it says you may not enter. Did you hear that? Okay. Now if I do it friend with a capital F.
Welcome, friend.
Says welcome friend. Okay. All right. So how did we do that? Yeah. So basically this is about using the accelerometer to speak. Yeah. Let me just get rid of the code, and this time I'm just going to put it into the backpack. So let me show you what the backpack is. All right. So the backpack is where you can just save code, and you can pull it back from there into your program later, or it will always stay in the backpack. So you can use code between programs using the backpack. So to see the backpack, just click on it, and there's already a bunch of some code there. So I'm going to take this code and drop it into the backpack. You can just right click on it and say add to backpack, and then I'm going to delete it. Add to backpack and delete it. Delete. Okay, so shaking the accelerometer to make the app talk. Move this zoom window out of the way. Okay, screen is empty now. Let's go back to the designer. So what I have here is the accelerometer sensor that I picked from the sensors drawer. From all the sensors here, the accelerometer, okay? And remember, when we drag and drop sensors and non-visible components onto the screen, they just stack up here horizontally below. What else do I have? I have something very interesting called a text-to-speech component, all right? Where did I find that from? I think from the media drawer. There's a text-to-speech component, all right? So what it does is it will take a message and it will just speak it. If you use Amazon Alexa or Google's version of that, there is also a speech-to-text component, but we'll use that another time. This is the text-to-speech. Actually, you can see that right here, speech recognizer. We'll use this in a subsequent app, but if you want to build an Alexa-like app, this is what you need. Today, we'll just do the text-to-speech, and let's go to blocks now. Oh, I also have a button and a text box, just a funky thing that I did. But yeah, the main thing is we want to play a message when we shake the phone. All right, so go to the accelerometer sensor and which of the events do we need? So by now you're probably figuring out as I talk, we are going to need an event and a response. The event would have to do something with the phone shaking. That's why we have the accelerometer. And so there are events that are generated by the user when they click on a button or when they tap on the touch screen. There are also events that are generated by sensors. So accelerometer will detect acceleration in XYZ dimensions, but it will also just simply tell you, is the phone shaking or not, right? So there's a shaking event for that. And then what do we want to do? We want to play a text message. So I'm going to grab the text to speech component and just put it into the callback. So this is my event response. But I need one more thing, right? I need some text to say. What would you like me to have the phone say? Just put it in the chat box. I come up with very boring things. Let's say like, welcome to Women Who Code. Or let's do something else. Women Who Code. Rock. Okay, am I allowed to say that? Yeah, okay. So that's it. And yeah, all women rock, not just Women Who Code, but yeah, just to keep this moving. So yeah, but there's no way I can demo this right in the emulator. So here you're seeing one of the limitations of the emulator. I cannot shake this, I cannot shake this and have it play, right? But yes, if you transfer this to your Android phone, you shake the phone and it will work. And let me take this opportunity to just say there's one other way to transfer this to the phone. So right now we are using emulator. If you pick AI companion, then what it will do is it will generate a QR code for you. You know what a QR code is? Just in case you are not familiar with QR codes, although I think nowadays everyone is, most people are. My kid was telling me something about QR codes at the school today. There are these codes that look like this, right? So if you decide to do the testing on your Android phone instead of the emulator, then you choose AI companion instead of the emulator. It will generate a QR code. And when you scan that QR code, it will download the app to your phone for you to test it out. But you do need a companion app for that. That should already be installed on your phone. So I'll put some notes in the Google Classroom. But be aware that that's another way to test it. If you get tired of the emulator and want to test things like shaking the phone, then you need an actual phone and you can do that. Yes, I was saying that, okay. So since we cannot test the shaking of the phone in the emulator, that's why I put this text box there. I put a button and a text box. So let me show you what I did. The button, by now we are all familiar with the button. Buttons are friend. And I picked text box. So if you see, there's a label and there's a text box. The difference is a label is just a text label, okay? So a label just allows you to put some text there, like some text to show. Yeah, but the text box actually allows you to give input, text as input to the app, okay? Actually, you can actually get the text on the label as well as a text box, but a text box is a way of collecting input from the user. So it gives the user a form and the user can enter data into the text box. So this is what you can do to modify this if you want. Like what I did here was I just took the button and to practice a little more about the if then statement, went to the control, took an if then else, right? Because what do I want to test for? So what I want to test for is if the text in the text box is friend, right? Then say something, otherwise say something else. So how are we going to do that? So I want to know what's in the text box. So where do I go? Probably go to the text box. And out of the get set methods in here, what I want is the color. No, I want the text. But this is just telling me what is a text, right? So remember, the condition has to evaluate to true or false. So I need to test that this text is friend. So the way to do that is go to the text drawer and grab this compare text. You can compare numbers, you can compare text, and you can compare even other elements like buttons, etc., other components. You can just compare any object in App Inventor. But most commonly, what we compare are numbers and text, right? So we don't need this. We're going to need compare text. We're going to take the text box text, move this zoom out of the way, get rid of things I don't need. All right. And what do I want to test this for? I want to test that it is equal to friend, right? Friend with a capital F, right? And if this is true, then what do I do? Then play the text to speech component. So then speak some other text that I'm going to give you. Just say, if it is equal to friend, then say welcome. So it's just going to say whatever I type here. And if not, just going to duplicate that code and change it to maybe not welcome. That's kind of rude though, isn't it? All right. And now we can test this out. And hopefully, let me make sure that this is refreshing. So one way to make sure that this is refreshing is actually quite simple. You know, just go to the designer and change the screen label. How do you have the app dock? Oh, this font is so small. Instead of the phone, I'll just say when phone is shaken. Let's see if that reflects in the, how do you have the app dock when phone is shaken? Yeah. So it has updated, and going to put friend here.
Welcome.
Okay, so I typed friend and it said welcome. All right. Okay, so that was a bit of a deep dive into if-else statements and also using sensors for different events. We'll dive into other sensors in just a minute. Just for the sake of completion, 436. I have dream app. Okay, going back to that. So here also I put in an accelerometer. I don't know if I did this the last time. And when we shake the phone, then it plays one of those two speeches. So this is one example of how you could use it. Let's go back to my projects. All right. What else do we want to do? When do you use a variable? Yeah. So let's go to that one. When to define a variable. Yeah, so we didn't use a variable last time we built the app. And what is going on here? Does anything actually happen? Let's see. You see the blocks. Oh yeah, something does happen. So just watch what happens. All right. So what I programmed this app to do is every time I touch the screen, it draws a small circle, and then the circles keep getting larger. So since I'm doing this in the emulator, I'm not going to touch it. I'm going to click with the mouse, right? So there's a little dot, tiny little dot. Can you see? Now I keep clicking and the dot doubles in size. Okay. I'm just going around in a spiral pattern. Doubles. Actually, it's not doubling, but it's growing in size by some ratio. Okay. All right. Then pretty soon it's going to take up the whole screen. So this is a demonstration of when do we need to use a variable. All right. So let's get rid of the emulator. Yeah, so the designer is very simple. It just has the canvas element. And where does the canvas element come from? From drawing an animation. Okay, canvas element. So that's all there is. I'm going to go to blocks. And I'm going to put this into the backpack. He's getting a little tired. Delete blocks. Just let me see what I did here. Okay, just multiply. Delete, 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 delete. Where is delete? I had a dentist appointment very early today. I'm feeling a bit drained. Okay, I'm just going to put this out here. But this is so much fun, right? All right, I got rid of all the code. And what we are going to do is, save the empty screen. Yeah, so there is a touch event for the canvas, right? Like there's a touch event for the button. And the touch event for the canvas actually does a lot more than the touch event for the button, which just tells you whether the button was touched or not. It does a little more. So the canvas touched event basically tells you the X and Y coordinates of where did you touch the canvas. And the X and Y coordinates are like the origin is 0, 0, which is the top left corner. And then as you go to the right, the X increases in units of pixels. And as you go to the bottom, the Y increases, right? So 0, 0 is the top left corner. That's the only thing you need to know about the canvas coordinate system. Actually, this coordinate system also applies to anything in App Inventor. The top left corner of any object is 0, 0, 0, okay? And so when we touch the canvas at an X and Y coordinate, we want to draw a circle centered on that X and Y coordinate. So the canvas has all manner of methods to draw circles, lines, points. And this is how you can draw on the smartphone screen, So when you can actually use App Inventor to draw on the phone screen, you'll be using, like, for example, draw line, okay? You can also draw circles, rectangles, polygons, what have you. And you can draw them in any color, any transparency, etc. But for today, we are just going to draw a circle. And so I'm going to look for the draw circle method. Here it is. Okay. And yeah, whether it is filled or not. And what you need to draw a circle, you need to tell it the center. So the center is the X and Y coordinates where I touch the screen. So how do I get those? So the way to get X and Y coordinates, the event itself returns the X and Y coordinates, right? So if I hover my mouse over the X, then you see the get and set for X. I'm going to grab the get X and put it center X, okay? So to draw the circle, I need to tell it where to center, what is the X and Y, and then what is the radius, all right? So same way I'll get the Y, I hover the mouse over Y, get Y, okay. And radius to start with, let me just give it a constant. So I'm going to go to the math drawer and grab a number, and let me just call it 2. So what is this going to do, right? Let's see in the emulator. Again, let's refresh the companion screen. Okay, I touch it. Every time it's going to draw a circle of radius 2. It's pretty small, but you see all the dots on the screen? See them, right? Okay. Yeah, but this is not what we want. What we want is, we want that every time I touch the screen, the circle is a little larger in size. So how am I going to do that? So one way I could do that is I could take, if circle had radius as a property, yeah, then I could just get the current radius using a get method. And then I could set it to 2 multiplied by whatever it is, right? But you see, I only have canvas and screen. I don't have a circle anywhere. Yeah, so I don't have a get set method with a circle object. You see what I'm saying? But there is a way around this. I mean, there is a way to go ahead, which is I go to variables, right? So anytime I want to store data in my app, anytime I want to give my app memory, then it's like my app has a small spreadsheet that I can use that's called variables, right? And if I click on variables, there's not much in there. There's global, and then there's local. And we'll understand this as we build our next app, the Mole Mash app. But today we are just going to use a global variable. and take global and drag it to the screen. Now what this means is now my app has memory, and I can call this variable, let's say radius, okay? And so it's going to remember the radius in this little spreadsheet, okay? I'm saying spreadsheet conceptually, there's no spreadsheet that we can see on the canvas, right? Yeah, but it's what the app is using to keep track of information like radius, right? Elements that I've initialized here. So I'm just going to give this I'm going to move this number 2 to radius here. So now it remembers that radius is 2, all right? And so when I want to supply the radius, when actually it comes to drawing the circle, when I touch the screen, I'm going to get it from the global variable. So you see, when I hover over radius, it has a get and set methods. And I'm going to start with, I'm just going to get the global radius, and that's it. So go back to my emulator, refresh the screen. Yeah, and again, when I click on the screen, it's drawing all these little dots. So what did we achieve? I created a global variable, and now instead of hard coding the radius in the draw circle method, I'm just getting it from the app's memory, right? But what I really want to do is every time I get it, I want to multiply it by some factor, let's say 2. So what I'm going to do is then I'm going to use math and use the multiplication method. I'm going to say get the global radius and double it, all right? And then remember, the global radius also has a set method. So I can not only get the current value, but then I can also change it in the app's memory. So I'm going to say set it to this multiplied by 2, right? So actually, I'm going to duplicate this, not just this. I'm going to duplicate this whole thing and do that. All right, so you see what's going on here. I'm getting the global radius where from this global variable. I'm getting the radius from this global variable. And then I'm resetting it. I'm changing its value. I'm mutating it to twice of what it was before. And the app is going to remember that, okay? So if I did this right, then what should happen is now every time I click on this, see it's doubling in size, okay? So this is a simple example of when we need to use variables, and it basically tells us that, yes, if we want to give our app memory, then there is a way to do that. The simplest way is to use a variable. You can also use a database, and we'll be doing that in the third app that we built called the Pong app, all right? But for now, just do it with a variable. I think we are almost at the end of what I wanted to do here today. Oh, and one interesting way I used it in the previous app that we built, I have a dream app, is actually I'm using a text-to-speech component to say something when the recording, to say a message when the recording has finished playing, okay? So there is a dot completed method associated with player. So if you go to player, you find a dot completed method, which is when the recording has completed playing, do this, all right? And so do what? What I'm doing here is I'm just I put a footer in there. So the footer, so remember we have 2 players, right? There's a player for Malcolm X, there's a player for Martin Luther King. So I would need to have this in 2 places. When MLK player completed, play the footer. When Malcolm X player completed, play the footer. And then if I decide to change the message that I'm going to play, then I have to change it in 2 places. So instead of that, what I've done is I've defined it as a global variable. And here I've called it footer, that's the name. And it's brought to you by Women Who Code St. Louis, right? And so now when I call the text-to-speech component, I just pass it this variable. So this is just a way I've used the variable in the last app that we built. We'll be using variables a lot more, starting from the next app that we build, which is the animated game called Mole Mash. All right, and I think that's it for today. I think we went through all of these except how do you stack buttons next to a picture, right? Yeah, we'll come back to this another time. Any questions so far? There's it's very silent in the room, so I've been talking a lot. So I hope you guys are following along and I have not confused you.
I don't see any chats, but also feel free to unmute yourselves
Yeah.
if you don't feel like chatting.
Absolutely.
I am a complete newbie to any of these things. And my background is all art, so this has been very, it's like starting out with a completely different language. So I appreciate it. I'm just kind of taking it all in and then going back and watching the videos so that I can understand it a little bit better.
Awesome. Awesome. Yeah, it's a very courageous thing you're doing, right? I mean, you're right, Mary. It is like learning a new language, right?
Yeah.
And really, that's all it is, right? You're just learning what are the nouns, what are the verbs, right?
Mhm.
And how do you use the nouns and verbs when you want to make your own sentences, right? And like get and set, these are verbs, right? But like an audio player is a noun, right? A source file is a noun. So I really like your analogy. It's really like just learning a language, just that it takes a little getting familiar with what the nouns and verbs are, and then pretty much after that you're making your own sentences, writing your own stories, and that's your app, right?
I hope. Thank you. I appreciate the opportunity to do this. So thank you.
Yeah, and hang in there. Like there's always I'm always available to for one-on-one sessions or during office hours if you want to clarify some concepts. Okay.
All right. Thank you.
Yeah. Okay. Good. So this one, I think for the rest of the day, let's just go a little easy on ourselves. I want to share with you something about sensors. I don't think we'll get to layouts. We'll do it another time. Yeah, but it might be coding overload if we do too much at once, right? I think I'm going in reverse. Okay, there we go. And yeah, I just wanted to start by saying that we've covered these concepts so far. What is the event-driven pattern? How to make layouts on the screen in front of the user, how to use sensors. And there's an app that I use every day for meditation. It's called a journey app from the Art of Living Foundation. Disclaimer, I'm a volunteer with the Art of Living Foundation, and I'm not pitching this app. But I just wanted to let you know, this app is actually a soundboard app. That's all it is, right? I believe it has some 450 million users, I think, between Android and iPhone. And what it has is it has daily meditations. So you click on a tile and like enhancing sleep, reducing stress, managing anger. I think these have some knowledge sessions. But if you look below, there's this 5-minute, 10-minute, 15-minute. It's not fully visible in the screenshot that I took. But what these are 5-minute, 10-minute, 15-minute meditations, right? So just before I came to this class, I had like 5 minutes and I did a 5-minute meditation. But the interesting thing is, everything from these 2 sessions that we've had to build an app like this. And this app, I think it starts with $6 a month. It has 450 million users. So what you have learned is so powerful, right? When you find the right application for it. And all this has is really buttons, which have these colorful, soothing pictures on them. And when you click on a button, it plays an audio file. It plays an audio recording. And you know how to do that already. So you can build apps like this, right? So I just wanted to bring that up because what you're learning is pretty powerful. So don't think that because our examples, they are relatively simple, so we can pack everything into 1 hour. Don't think that it's a toy problem. You can actually go ahead and build apps that solve problems with even what you've learned in just the first class. I think I'm not finding my way around. Okay, so yeah, let's get a little bit. This is just PowerPoint. I like to use memes to explain concepts from engineering. Let's see how this works, right? So the first meme I want to just dive into a little deeper is the event-driven pattern. And we've used it several times so far, right? In the app that we built, in the exercises we did today, there is a very simple way of thinking about it. When you order a package from Amazon, right? Do you go to the door every 5 minutes and check, has the package arrived? Has the package arrived? Has the package arrived? Has the package arrived? That would be insane, right? What happens instead is when the package arrives, the delivery person rings the doorbell, and that's when you go and pick up the package, right? So both these patterns exist in software development. You can write software in a way that you check every 5 minutes or at some regular interval whether an event has occurred, right? You wouldn't want to do that necessarily to check if your package from Amazon has arrived. That would be silly, right? But yes, you can write software that way. So there is a whole branch of coding in engineering called programmable logic controllers. And that's all a programmable logic controller does. So oftentimes when you have Christmas lights, those Christmas lights, the logic to operate those lights, like, you can play some music and those lights respond to the music that you're playing. You can do funky things, right? So they use programmable logic controllers, and the way a programmable logic controller works is the first idea that I sketched, which is it just checks over and over what is happening, and then it responds accordingly. What we are using in building apps with App Inventor is the second approach, right? Where the delivery person rings the doorbell and then we go and check whether we go and get our package. So this is the when do. The event-driven pattern is nothing but when something happens, do this action. When the doorbell rings, do pick up package. When the button is clicked, do play the recording. Yeah. So if you're new to technology, if you're new to coding, it might seem like, oh my God, these are such big words, event-driven pattern. No, it's really simple, right? And we do it every day in our life. Okay. You can also write, I also teach Python programming. And the interesting thing is most Python programs are not in this event-driven pattern, right? So a Python program will just start, take action, and then finish. And the only thing you can do with that is the first approach is called polling, where you keep checking, has my package arrived, has my package arrived? So when you code in Python, usually it works like that. When you code in JavaScript, it usually works based on the event-driven pattern. When you code in App Inventor, we are using the event-driven pattern. So event-driven pattern is very popular for mobile development, and you can see why, right? Because most of what your app does is in response to a sensor's event detected by a sensor, or an action, a certain action done by the user, right? So that's why. Now I want to talk about sensors a little bit. I want to talk about the accelerometer. We have already used the accelerometer. So what is the principle of an accelerometer? So you already know why we want to use an accelerometer. We want to detect acceleration or motion, right, in X, Y, and Z dimensions. Yeah. So when I hold up the phone this way, X is here, Y is here, and Z is here, right? So just the motions of my arms, okay? But when you think about how an accelerometer works, it's actually an interesting piece of engineering, because I like to think about it as when you run a washing machine, when it spins, in the spin cycle to get the water out of the clothes, right? The spinning motion pushes all the clothes out towards the side of that tub, right? And that's what they come out squeezed, right? And that's kind of the spinning motion is what squeezes all the drops of water out. And so the clothes come out relatively dry. You do have to still put them in the dryer. So that squeeze that the clothes feel, that is what an accelerometer does. So imagine each one of these pieces, each one of these items of clothing in the tub of the washing machine is your sensing element, right? And when it feels a force, it gets squeezed. And how much it gets squeezed is the reading that it reports out. Yeah, and it does it in all three directions, X, Y, and Z. So the principle of an accelerometer, although it's a very high-tech device, is really simple, right? It's nothing more than how these clothes get squeezed in a washing machine in the spin cycle. The sensing elements get squeezed when the phone moves, and then it reports out the extent to which it is squeezed in the X, Y, and Z dimensions. You can think of these as little springs. And the more they get squished, the higher the reading that it reports out. And when we are using this in App Inventor, there's a question, I'll come to that in a minute. You go to the accelerometer sensor, it has only two events, right? Shaking and acceleration change. So acceleration change will tell you in X, Y, and Z, how much acceleration did it sense in the X, Y, and Z directions. And if you want to use the raw sensor reading, then this is what you would use. But most of the times in a cell phone, what people want to do is to check if the phone is shaking, right? So in fact, when you turn the phone, then the display changes from portrait to landscape. That also uses the accelerometer, okay? So in that case, you would use the X, Y, and Z readings. But they know that most of the times when people use accelerometer in an app, they want to see if the phone is shaking. That's why you have a shaking method, which wraps around, which does some math with these XYZ values. And it gives you a ready-made way of just telling whether the phone is shaking or not. Just pause for a second. There's a question. Okay, we are getting close to the end of this session. So I have a JavaScript puzzle program. What package can you recommend to convert to an app? Oh, I'll come to this a little later. Okay, but you know, it's yeah, I'll come to that a little later. Right? It's this question is going to take some time to answer. All right. So yeah. Okay. Yeah. All right. Let's go back to the slideshow. The other sensors you have. So some of you already know that you have, for when it comes to motion, you have accelerometer, you have gyroscope, and then you have the GPS sensor. So the gyroscope, we're going to look at each one of these, and gyroscope is one of the most confusing elements, known to man in some ways, but in some ways also it is really very, very simple. Okay, when you start getting into the physics of it, it might take a little getting used to, but really there's an everyday object that we operate that uses the gyroscopes, where we are the gyroscope, or that object is a gyroscope, but we work with it, and that object is the bicycle. And if you noticed, the bicycle, when you're riding the bicycle, it's always unstable. It's unstable. It's falling to one side or the other. What you can try is you can just try locking the handlebar, and you won't be able to stay on the bike for long. It will fall to one side or the other, right? So you really need to be able to move the handlebar to keep the bike upright. And why this happens is any spinning wheel is a gyroscope. And what happens is when you try to move that spinning wheel, it precesses, okay? And let's see a short demo to understand what precession is. It's just a 2-minute demo. Can I just show this demo to you?
A spinning bike tire has a substantial amount of angular momentum. But a change in angular momentum requires a torque.
Can you hear? Okay.
This can be dramatically demonstrated by turning the wheel while standing on a low friction platform. Changing the rotational momentum of the wheel causes a change in the rotational momentum of the demonstrator. Rotating the wheel back cancels this. The conservation of angular momentum is a consequence of Newton's third law applied to torque.
Yeah, so very, very short video, but it's the principle of the gyroscope, right? So make sure this is working. Yeah, okay. So when you make those little movements of the handlebar, your body is detecting that your bike is listing to one side or the other. And those little motions of the handlebar, tilting the front wheel of the bike, the precession that it causes offsets the listing. Okay, so your bike is falling, your body detects that. Your mind is the computer that says, okay, how much do I need to move the handlebar to offset that listing motion? So you twist the handlebar just that much. And the precession, as you saw in the video, as she was rotating the wheel, she was turning herself, right? So that is precession. So the precession offsets the list, and then you come back, and then you start falling on the other side, and then you keep making those continuous adjustments to the handlebar. And isn't it amazing that our brain learns to do that, even without knowing anything about the physics to start with, right? When I learned to ride a bike, I didn't know anything about gyroscopes, but our brain just learns that. So with the gyroscope sensor on the app inventor, you can actually get it from the sensors drawer. So you can access the, we need to drag and drop it here to actually see what it has, right? Yeah, let's find it. Where is it? Gyroscope, yeah. So you see the angular velocity in X, Y, and Z direction. So the way I like to think about it is the accelerometer tells you whether you are moving in X, Y, and Z dimensions. The gyroscope tells you whether you are turning in the X, Y, and Z directions, okay? And if you want to do things with turning, like moving if the phone is moving like this, then that's the accelerometer. If the phone is turning, spinning in any way, right? That's what you need to use the gyroscope for. So actually, when you switch between the portrait and landscape modes on the phone, it uses the accelerometer. Yes, but there are when you play a racing game on a phone, then the game uses the gyroscope sensor because you have a steering wheel on a car, for example, and as you play the game, you drive the car on the racetrack, you're actually moving the phone, right, to operate the car. So to build apps like that, you only need the gyroscope, and it's right there for you in App Inventor. All right. So I'm just giving you a little bit of knowledge about how these sensors work, and this is the last one, the GPS sensor. No, we are a little over time. So the GPS is the third in the triumvirate of sensors for detecting motion. So yeah, this is one of my favorite clips from the movie Pulp Fiction. He looks really lost. Yeah. So when you're lost, what do? You use a GPS sensor, right? And again, the principle behind the GPS sensor is very, very simple. So let me show you a 2-minute video to just explain the principle behind the GPS sensor. Okay, for some reason it won't play. All right, that's fine. So you can try this thought experiment, right? You just close your eyes and, well, we can't do it right now, but this is what you would do. You would close your eyes and ask a friend to walk on a tiptoe in the room around you. And when they are comfortable, they can snap their fingers. And I grant you that just by listening to the snapping sound of the fingers with your eyes closed, you can point to the direction in which they are, right? And you can do that very accurately. And do you know why that is? So that is because our ears are a slight distance apart. That distance is called azimuth, okay? And what it does is, when the sound comes to us from any direction, it arrives at one ear at a slightly different time from the other ear. And our mind again has learned to triangulate from the time difference, because sound travels at a constant velocity, what direction the sound may be coming from, right? So we can actually see this here, right? Assume that, yeah, so if you look at the sound source in this picture, yeah, it is asymmetric with respect to the ears, right? The sound is coming in at an angle, so it arrives at each ear at a slightly different time. And if we were to assume two microphones instead of the ears, so let's say the mic 2 is my left ear and mic 1 is my right ear, then basically the time difference would mean that the sound is coming, the sound source has to be somewhere on this parabola, which actually straightens out to a straight line. And that is why we can so easily and comfortably point to the direction in which a sound source in which a sound source is located. Okay, if I want to know the exact location, then what do I need to do? So if you think about our thought experiment, we could add another person in the room, right? And these two people pointing to the sound source would tell you exactly what the location of the sound source is. So person 1 would point, it's coming from there. Person 2, who is at a slightly different location, would say it's coming from there. And you would take these two straight lines and see where they intersect, and that would be your location. And this is what GPS sensing is based on, except that you have satellites which keep making these snapping sounds that your phone receives. And because we already know the GPS satellites, they form a constellation. So we know exactly the distance separating each satellite, just like we know the distance separating these mics, or we know the distance separating our ears. We can triangulate with 3 satellites what is our exact location on the surface of the earth. You see what I'm saying? It may seem very complicated, but it's all it is based on. The physics of it is just, the same as how we can locate the direction from which a sound is coming to our ears, right? Isn't that amazing? I find it pretty interesting. And nowadays, many cities like Washington, DC has, I think, the highest number of shootings in North America, or maybe it is Chicago, I don't know, but one of those cities. What the police are doing is they have these microphones on high buildings, on high rises, and they have several of these, and you need only 4 microphones. And anytime there is a shooting, from these 3 or 4 microphones, they can pinpoint the location where a gun was fired, and they can reach there immediately by a helicopter or a patrol car. And it's amazing that they don't even need anything else. Just these microphones on the top, 3 microphones on the top of buildings tells them exactly where a shooting has occurred. And the same technology is available to you on the GPS sensor on the phone. And it is one of the most interesting sensors to use, I think, because one of my apps is every day I go for a walk, and I've built a location tracker that tells me how far I've walked, and it counts my footsteps, and it tells me on a map what was my route. Yeah, it draws it on a map. I'll show this app to you another time. But yeah, so for that I use a GPS sensor, and it's accurate almost within 5 feet. Okay, so it's pretty accurate. I think this is a lot for today. Yeah. Let me stop sharing. Yeah, I didn't cover everything I wanted to, but I think let's take a pause so as to not overwhelm you. Yes, and I can maybe. Oh, somebody's meditating. That's awesome. Okay. All right. So here I am. And any
Thanks,
questions
Sanjay.
today? Yeah.
This is really interesting.
Thank you.
That noise you hear is my dog. She's whining.
Okay. The dogs are good meditators.
Thank you so much. I really learned a lot today.
Awesome.
I can't wait till the next session.
Awesome. Thank you so much. That makes me very excited. I love hanging out with you guys and sharing. And yeah, we have officers on Friday. So some of what I could not cover today, I can cover there or in the next class. But we do have a lot of content to cover. 1 hour turns out to be not sufficient. Yeah, but we'll keep going. And yeah, do ping me on Google Classroom if you're stuck somewhere. My recommendation to you is if you get stuck somewhere, don't remain stuck for long, okay? Especially at the beginning, because there's no reason to. You're learning, right? So it's going to happen. You'll get stuck somewhere or the other. So just get help, because there's no point in just, I like to say, there are no brownie points for suffering. I want you to be as happy and joyful as possible in this whole experience. So don't remain stuck for long. I do expect you to try and tell me, what did you try that didn't work? But don't remain stuck for long, and don't frustrate yourself trying to figure it all out. You're at the beginning of your journey. So just call for help, and I'm here to help you, and use the office hours. All right. And with that, let's close today's session, and I'll stick around for questions if you have any. Otherwise, we'll see you next time. Thank you so much.
Thank you.
Thank you.
Yeah. Bye.
Bye-bye.
Okay, I guess. Any questions? I don't see any.
Yeah. Yeah, Lutz, we cannot hear you very well. If you have a question, you could also put it in the chat box. You have a question about this JavaScript puzzle, right? You know what? If you have time on Friday, maybe we could get together and let me have a look at what you have built. There is a way to inject JavaScript into App Inventor. Actually, I was going to come to that in the 4th app that we built, so towards the end of our course.
Okay.
So it would be a little more advanced. It would take a little more advanced skill than what we have right now. But by the time we get to our 8th, 9th, and 10th session, right, day 9 or 10, really,
Okay.
I think, please, I will ask you to be a little patient and wait until then.
Yeah, I'll wait.
Yeah, we do
I'll
need to
wait.
build up momentum. Yeah, but there is a way to
Yeah.
do that, and I'll be a little more intentional about that as we get towards the later sessions. Okay, so you can convert your JavaScript app into a App Inventor app. You can package it to work in App Inventor.
Yeah, my interest is to modify the one that I have, that
Okay.
JavaScript program, and then modify it for different types of puzzles for children. That's what I was thinking.
Awesome. I would love to
Yeah.
know more about that. So if you don't mind, can you make a small video of what you have, or you can show it to me on Friday or at some time, some convenient time. And I can start
Okay.
thinking about what it would take to, let me understand what is the full scope of what you're trying to do. I think children's games are a great opportunity with App Inventor and also with any other technology, but I think they're a great opportunity to engage the younger generation in productive tasks. And so I would love to be of help as much as I can there. But no, I mean, let me see what you're up to, and let me
Okay.
answer your questions with that broader vision of what you have in mind, not just a slice of it. So we'll get to it. Okay.
Okay. How can I forward you the information? Is there a link on the materials where I can forward this to you?
To forward it to me, you could just post it on Google Classroom if you're
Okay.
comfortable doing that, or email it to me. What is it? It is a JavaScript file.
It is a JavaScript file, right?
Yeah, just email it to me if you're comfortable doing that.
Yeah.
Or on Friday at 4 o'clock, I can meet with you and you can just give me a live demo if that's okay with you.
Oh, okay.
Yeah. Or at Friday anytime. Doesn't have to be 4 o'clock. You let me
Okay.
know when, after 4 o'clock though. You let me know when, and I'll make some time to understand and appreciate what you're up to.
Okay.
All right.
Thank you.
Awesome. Stick with it. It's awesome what you're doing.
Thank you.
All right. Take care. Bye.
Take care. Bye-bye. You take care.
I guess I should stop recording.